Hey guys, we're gonna check once again the difference between potential and kinetic energy. Last time we got some topics we were talking about and we couldn't continue. And I would like to explain a little bit about the way these two types of energy work together. Here we got a simulation. You're gonna find the simulation included in our next activity. And what you're going to observe, guys, is that when I move my skater up, the amount of potential energy increases, right? Check here, guys. The amount of potential energy increases as high the skate is from the ground. So now check how this potential energy is transformed into kinetic. You see? So guys, what does it mean? To make movement, we need to have a difference between potential energy and kinetic energy. I would like you to try by your own with the different types of trips we got here. But the point is being pretty clear to understand how this difference in potential produces movement. When we got a lot of potential here, we got movement, right? But if we have here no potential, we do not have any movement. So basically what we are observing is that difference in potential energy, that difference in position is the one that produces movement, right? How is this related to a battery? How is this related to a circuit, to electricity? It's kind of the same. It is not about a mechanical position, it's not about a mechanical way like here, a difference in place or a difference in forces. But it is basically, guys, a difference in potential energy. Check, guys, this battery. I'm gonna take this battery out of here. You already know how to use this tool. And I'm gonna use here the voltmeter. You found it over here. I took it out. And I'm gonna measure how much power this voltmeter has. This voltmeter, not this battery is producing. It has 9 volts, right? The electricity is going to move from high potential, 9 volts over here, is going to make a movement and is going to return over here with a difference of 0 volts. Something similar to this, from high potential to low potential, right? The same principle of high and low potential is going to be set or applied here. In this case, it differs a little bit because that difference is given by the voltage. I mean, this is voltage itself. We're going to see it in a moment. We're going to have another explanation about it. Let's get started, guys. Checking here. And let me measure that voltage over here. So guys, remember the electrons are going to move from high potential to low potential. And now my reading is 9 volts. But check, guys, what happens if I measure here. What is my reading? It's 0. It means electrons are moving from high potential, 9 here, to low potential, 0 here. It's kind of alike to this, right? High potential to low potential. The same principle of motion is also applied for circuits. We're going to see now that in the laboratory. Bye.
5 minutes later.
This is a transformer. What it does is basically taking the energy from the outlet, which is 220 watts, and convert it into a small amount of energy. For example, in this case, we're converting that amount of energy into 2, 5, 8, or 12 volts, right? So we're taking higher power, higher amount of electricity, and converting it into a small amount of electricity. What I'm going to show you guys is an experiment, a demonstration that we were working before. Do you remember the buzzers? This buzzer frame we had? Basically, guys, what we are doing is moving the electricity from a high potential place, which is this one. Check here, we got a voltage of 8 to a low potential place, which is this one. What is the voltage you can see here, guys? No, let me try to focus. If we cannot focus properly, it's not that easy. Let me tell you, it is 0. So we are passing from 8, to 0 here. And I'm going to show you guys the way this works. I'm going to connect it here and check this nice sound, guys. It's super nice. Whoa. Why is this passing? Why is this electricity moving from here to here? Basically, because there's a difference in the amount of power we got here. Here we got 8 volts, and the electricity is going to move from 8 into 0 because of that difference, right? If we will have 8 to 8 or 0 to 0, the electricity will not move. You see? So guys, that's the reason why electricity moves. It moves from high potential, high voltage, to places of low voltage. So let's understand what voltage is. Voltage is basically the difference in potential between one place that has more potential to another one that has less potential. When you find something that says 3 volts, it means that has 3 volts and is going to be passing that electricity. For example, if we think on a battery, let me take the battery from here. I'm sure I've got one. Check this one, guys. This battery is a 9 volts battery. This battery is going to pass those 9 volts to an object and is going to collect again here, guys, the 0 volts because of the difference in potential. Is it clear what the difference in potential is? Let's recap. The difference in potential is named voltage. And as bigger the difference in potential is, bigger the voltage is. Clear? Hands up if you're understanding. This one is named a voltmeter. A voltmeter is a device used to measure that difference in potential. The difference in potential we can find from here 8 to here 0. So let me tell you guys the way this works. Here you're gonna find, guys, that we got different ways to measure. This in particular can measure 3 volts as a maximum of 15, 30 or 300. Some other device can measure even bigger quantities of voltage or smaller, giving us more precision. But this is the way this one works. Remember, we're working with 8 volts over here, and now I'm going to show you that reading. So check, guys, we got the reading over here between 0 and 5, and then we got here 10. Do you see it? So we are basically in between. So 5 and 10 volts over here. We're getting almost those 8 volts, like 6 point something or 7 volts I would say. So now we're seeing that electricity is passing through it. Let me show you now, guys, other device. This device is named an ammeter, and what it measures is basically the other characteristic of electricity. In this one we are measuring how many volts, what is the difference in potential between one position to another one in a circuit. But in this one we're going to measure how many charges are going to pass through it, how many electrons or charges. Let's name them chargers because there's actually another word that I would like to introduce later, but let's name charges. So how many of them are passing through the circuit. So what I'm going to do, guys, is connecting this here and start checking. Oh my gosh, it's less than this. I'm going to show you with 5 amps, and we're going to find how many charges we got. In this moment, guys, check this reading over here. We're getting 3.2 amps in this case. Guys, why are we working on this? Why do we need to understand volts and amps? If we got these two ways to measure electricity clear, we're going to be able to record if electricity is passing through or not. I hope you understand it. Let's continue with a short experiment in a moment.
5 minutes later.
Now we're going to try to remove some electrons from this conductor. Check this coil we got here. All this is copper, right? And we're going to try to remove electrons from this coil of copper, which is a conductor, using these magnets. How many can we remove? Actually, not too many of them. Why not too many? Because we don't have a pretty powerful magnet, and because I cannot make this move pretty fast inside. But what I want you to understand is that basically when we have a conductor and we got a magnetic field through that conductor, that magnetic field can take those electrons away from the conductor and start moving them, right? We're going to check that later using a simulation. You're going to be working on it. It's going to be kind of interesting. I'm going to show you some of them, but I would like you just to check here the numbers. Please, guys, check the following. We're going to be measuring milliamps just to try to find out how many charges are being removed just by passing this magnet. What I'm going to do is passing this magnet, putting the magnet in and out of this, something like this, just for a while, guys. And I want you to check how this is changing. If you see, guys, the change is not something we can perceive, and it is not so organized. I mean, the electrons are being moving in one direction and then in the other one, and that's why we got this changing, which is like in two different directions. Even though we can see that some electrons, some electricity is being removed out because those electrons are taken away from the conductor using a magnet. So guys, we can use this tool in order to produce electricity. This is named the induction principle. Basically, is a way to remove electrons from a conductor using magnetism. And that's why many times when we are talking about electricity is basically connected to magnetism. There's a way to name this energy, guys, which is electromagnetic energy, right? So why? Because one can be gotten from the other one. They are closely related.